Hi everyone. In this video, I will explain Evaluator-optimizer type of workflow in LangGraph. In this flow, what happens is that some output is generated by one node, which is usually an LLM, and then the output generated by that node is evaluated by another node, and then the evaluator tells whether the output generated is up to the mark, it should be accepted or not. If it is accepted, then it directly goes to the end and the output is finally sent to the user. But if it is rejected by the evaluator, then a feedback is also generated, and then the feedback goes to the generator again, and then the generator, based on the feedback, tries to improve the output. And then this can go on until the output is finally accepted. So in this example, so this is what is happening, right? LLM call generator will generate some output, then it will go to evaluator, and evaluator will tell whether it should be accepted or rejected. If it is accepted, then it is good. It will go to the end, the output is generated. But if it is rejected, then we also ask the evaluator to give the feedback that what is the problem with the output that is generated. Then the feedback goes to generator again, and then it will try to improve based on the feedback and send it again to the evaluator. Now again, the evaluator will evaluate and do the same thing. There is only one problem with this flow, that chances are that this loop can go on forever. Okay, so chances are that whatever output is generated, it is never accepted by the evaluator, it is always rejected. In that case, it can run into an infinite loop and it never end. So in that case, we have to put together some max iterations kind of mechanism where it will only run for n number of iterations. It will not run forever. Like if we have reached the maximum number of iterations, then also it will return an output, whatever it is, whether it is still accepted or not. But this is very important because otherwise chances are that we might run into infinite loop, and which is not good for the output also, and then the token limit also can get exceeded, and then the LLM will charge a lot. So that is not good for the program also. So for that reason, we have to put this additional step also in place. So let's see how this whole thing works in code, and I will try to uh, demonstrate this through all possible examples where it is accepted in one go, where it is rejected first and then accepted in the second go, where it is never accepted by the evaluator, but still we return the output after the max iterations are reached. So all the examples I will explain, and I will show you how to build this. So let's go to the notebook. So we will start with all the necessary imports. We will initialize our LLM. Here, the LLM that we have used is from Grok because it is free. If you want to understand how to use Grok API for free in LangChain, please click on the link in description. Now let's start building the graph. So in the graph, the first step is defining the state. So in the state, we have field called topic, which will come from the user. Then we have a generate prompt. I will tell you in the end while running examples what these fields are required for. So generate prompt, then improve prompt, then max iterations. So this is also going to come from, so all these things are going to come from the user as initial state in the input. Okay, topic, generate prompt, improve prompt, and max iterations, till how many number of iterations it can run. Okay, then this is a joke which is generated by the generator. Then this is the feedback, which is generated by the evaluator. Then funny or not is also a indicator which is generated by the evaluator only. And then the number of iterations. So whenever we are running the generator, we will always increment the iteration to this field so that we can keep track of how many iterations I've done. And then we will keep comparing it with max iterations. Okay. So this is state. Next is the nodes. No, so this is the class of feedback. So the feedback, the evaluator will generate output in the structured format. For that, we have defined this Pydantic class. So the output will be generated in this format. It will tell us the grade. The grade can have only two values, whether it is funny or not funny. So here in this case, we are just trying to generate a joke from the generator. For that reason, we want to just understand whether it is funny or not funny. So that is a criteria. Then the feedback. Okay, so feedback will come if the joke is not funny, then it has to provide a feedback which will go to the generator again, and based on the feedback only it will try to improve the output. Okay, so now we have just defined our structured LLM using with structured output method and provided this class. So the output will always contain these two fields. Okay, So one will be a literal, which can have only these two values. Another can be a string. Now let's define the nodes. First is LLM call generator. So in LLM call generator, there are two things. Okay, one is that we are running it for the first time. In that case, this feedback field will never be available. Okay, in the state. So in that case, which means that it is running for the first time. So in that case, it will come here. So where we will simply ask, write a joke about this topic, and then we are also providing the generate prompt. So generate prompt, why we need it is that we will try to enforce it to generate content in a certain way. So let's say I want to say that never generate a funny joke. Okay, so in that case, the evaluator will never be able to accept it. Or if we say that okay, generate it not funny for the first time, but based on feedback you improve it. Okay, so for that reason I have integrated this so that I can try to produce all the possible scenarios. So these are the instructions coming from the user, and then simply, okay, so this is the first time. And then if the feedback is generated, then again also in case of rejection, it will again go to the generator. In that case, this part will run. So what it will do is that below is the joke generated. So this is the already generated joke, okay, about this topic. And this is the feedback coming from the evaluator. Now we also provide the improve prompt. Improve prompt will tell whether to actually improve the joke or never improve it, or keep it unfunny only. So this is also required only to uh, try to control the behavior of evaluator as well as generator. Okay, so these two things are really important to produce all the scenarios. Then just simply return the improved joke. That's all. Don't say okay, this is the improved version or something, because it is not important right now. The final output should only contain the joke and nothing else. For that reason, I have put it like this. So this is our generator node. Then we have the evaluator node. Evaluator node will simply just evaluate. It will grade the joke, and then it will, since we are using a structured LLM, it will generate the output in with these two fields: the grade, whether it is funny or not, and the feedback. That's all. Okay, so this is straightforward. We simply get the output uh, having two fields, grade and feedback. We will save that in these two fields, funny or not funny, and feedback in the state. Next is the conditional router function, route joke. Okay, so here there are three different conditions possible. Like I've told you, one condition is that it is rejected and it has feedback, then it will go to generator from here. From here only the conditional routing will happen. It can go here, it can come here, or it can come here. Okay, so these three conditions only. Here I have kept it like this explicitly, because if I was not creating any dummy node here, this is a dummy node which I will show you how it looks like. If I was not creating any thing like this, then only this route was showing on the graph and this route was not showing. So it was making it a little confusing that what is happening in this scenario, whether it is actually going to the end or not. For that reason, I have just kept it like this. I will show you how it works. Okay, so router will do, first condition it will check is that whether the iterations that we are incrementing. Okay, so yeah, so another point that I forgot is that whenever the generator runs, it will take the iteration from the state. If it is not there, then it will initialize it to 0, and it will always increment it by 1 and save it in the iteration. So first time it runs, it will become 1. Second time it runs, it will become 2, and so on. And then the joke is saved in this field. So this I forgot, but yeah, this is what it is. Then iterations at every conditional route, it will check whether the iterations have become greater than or equal to max iterations. Then it will go to max iteration reach node. Else if it is funny, then it will go to accepted. If it is not funny, then it will return the rejected plus feedback. So this is the output that it will generate, and we will map it to the respective nodes. So one more important point here is that this should be the first condition. If we keep it as a second or third condition, then chances are that in this case it will be a problem. Okay, if this condition is running after this, then chances are that max iterations will never be checked, because it will keep rejecting and then the iterations will keep increasing. Okay, so this should be the first condition that it should check. If iterations have reached, then don't check anything else. But if iterations have not reached, then only compare these two things. Either it will be accepted or it will be rejected. So this was a mistake I was earlier making. I was making this as a third condition. And in that case, the iteration check was never happening. because it will either accept or reject, and then it was just revolving around this only. Okay, but this should be the first condition. That is important. Now let's try to build our graph. We will start with state graph where we define provide our state that we have defined here. Okay, then we define our nodes. So the two nodes that we have are LLM call generator and LLM call evaluator. Yeah, so these are the two nodes, LLM call generator and LLM call evaluator. Then we define our fixed edges. Okay, there is one more node. Sorry, I forgot. So this is the node that I was talking about, which should be dummy. So the name of the node will be max iterations reached, and it will simply take the state and return the state as it is. It will not do anything. But this is just to separate this route from this route. If we connect both of these with the end, either of two will show. Both of them will not show in the graph. Okay. For that reason, I have created this dummy node. It will not do anything. It will simply take the state and return it as it is. Then another fixed edges from max iteration reach to end. Okay, this is also another fixed edge. Then we come to the conditional router. So conditional router will start from evaluator. It has three conditions based on the route joke router. So in this case, what will happen if the output of this router is accepted, then it will go to end. If the output is max iterations reached, then it will go to this dummy node. And if it is rejected plus feedback, then it will go back to connect back to the LLM call generator node. And then we simply connect the max iterations reached to end node. Okay. So let's try to compile it and display how the graph look like. And optionally, we can save it as an image also in our local machine. Okay. So this is how the graph looks like, which I've already shown you in the image at the beginning of the video. So yeah, so let's try to run this. Okay, this is, yeah, so we will try to run this for various different scenarios. So first scenario is that the output generated should be funny in first generation only. In how we will achieve it, we will just give a topic, and the generate prompt instruction we will give it is make it a pun, and so basically it will always be funny. Okay, and then improve prompt, make it funnier, we can give it, but it will never go at that place. So let's see how it works. So in invoke, although it returns a final output only, but when we try to stream it, then we can see, or if we try to print the state, we will be able to see whether there were multiple iterations or not. So there was only one iteration, and in first iteration only the output, the decision was it is funny. Okay, and if we try to stream it also, we will be able to see what all nodes ran and in what order. Here also, I'm giving an instruction that make it funny, make it a pun. So here, whatever output is generated, in first go only, it decided that it is funny, and in that case, based on this condition, it will directly come to the end. Okay. So second scenario is that it is unfunny in the first generation, but it gets improved after first feedback. How we will achieve this scenario is that we give the topic, the generate prompt is make it totally unfunny. So first instruction that will go to the generate prompt is this, that make it unfunny, and improve prompt, what we are saying is that make it funnier. So whenever the first feedback goes to the generation again, after that it will return a funny output. So in two iterations, this will be completed. So this will give us a scenario where it will happen like this. It generated, evaluated, rejected, and again generated, accepted, and come to here. Okay. So let's run it and see how the output looks like. And it is better to see the complete state. Yeah. So number of iterations two. And after the final second iteration only, it was changed to funny. So because we are just saving the latest value, that's why. So if you can see, feedback was also created, and then the final joke that was created was accepted. Okay. So if we try to stream it, then we will be able to see that the generate node will be called twice. So again, the same instructions. First instruction will be make it unfunny, then improve instruction will be make it funnier. So I can tell you how actually it is consumed. It is like in the first call to generator, it will only take the generate prompt. But in the second call, it will not take generate prompt, it will take the improve prompt. Okay. So second time only it will make it funnier. So let's try to stream it and see. Yeah, here you can see the generator. It creates a joke which is totally unfunny as per our instructions. Then the evaluator said not funny. Then the generator, based on the feedback, again improved that joke and made it funny this time. Okay. And then finally the evaluator says it is funny, and then we have ended. And then the whatever joke is finally saved in the joke field, it will be returned in the output. Okay. So the third scenario is that it is unfunny in the first generation also, and no improvement after feedback. So how we will achieve it? The generate prompt will be make it totally unfunny, and the improved prompt we will say is that make it even less funny. So improved prompt also will not do anything. This is to achieve the scenario where it will keep running, keep evaluating, but always it will get rejected. But we will stop the flow when this max iterations are reached. Okay. So here it will run for a while, and this is the final output, which is totally unfunny. But if we see the state, then the iterations it ran was for 5 iterations, and still it was not funny. But since the iterations were reached up to max iterations, this is also an input that comes from the user only. If he wants to try for 10 times, then he can say that I want to try 10 times. Okay. So then the final joke will still be returned to the user. So this I'm doing just to showcase that how all the scenarios can possibly work. And then if we try to stream it with these same instructions, totally unfunny in first generation also, and in improvement also, don't make it funny, make it even less funny. Okay. So let's run it and see how it is working. If you see, first iteration, decision is not funny. Second iteration, not funny. Third iteration, not funny. Fourth, not funny. Fifth also is not funny. And then after that, the max iteration reached node is called. Okay, and it will return the complete state. So that's why it is showing it like this. So this was a dummy node whose purpose was to take the state and return it as it is. Okay, so this in this notebook, I've tried to achieve all possible scenarios to demonstrate how this really works. So this was all for this video. Please let me know in comment section if you have any doubts or what other content you want to see around AI and in LangGraph. And please subscribe to my channel. Thank you for watching. Bye.